Good morning, learners. Welcome back to yet another video of mine. This video is on data structure using C, and in this video we will cover basically one topic from this subject. Unit will be graph and topic will be graph traversal. So for those of you who don't know what is a graph in data structure, let me tell you that graph is a combination of vertices and edges. Now what are the vertices and what are the edges? So vertices are basically like these, 1 2 3 4 5. This you are seeing, they are called the vertices, and edges, they are the connecting link between the two vertices, like between 1 and 2. This connecting link you are seeing, this is called edge. So basically we will study graph traversal. So graph traversal is of two types, BFS and DFS. BFS stands for breadth first search, and DFS stands for depth first search. Fine. So BFS uses the queue data structure and DFS uses the stack data structure. So if you don't know about the queue data structure and stack data structure, then don't take any kind of worries. I advise you to see the video completely, and in the end you will realize that you gained so much from this video, and you will be in the stage like you can solve any kind of question from the topic BFS and DFS if you watch the video till end and carefully. Fine? Means you should be focused. So BFS is there. We will start from the first one, BFS. So using this figure we will see what is BFS and what is DFS. See this figure you are seeing, select any vertex. Now right now I just told you what is a vertex. You can select any of the vertex. So I am selecting suppose 1. Fine. Now tell me what are the adjacent vertices of 1. To the adjacent I mean those vertices which are directly linked to the first. 5, 4, 2. They are the adjacent vertices. Why? Because they have direct edges connected through 1. So 5, 4 and 2, they are the adjacent vertices. You can write their name in any order. So 5, 4, 2 are the adjacent vertices of 1. So I think you gained this much, that you have to select any vertex from the figure and write its all the adjacent vertices. After this step you have to come on the other number. Other number is 5. After 1 there is 5. So what are the adjacent vertices of 5? 1 is there. Apart from 1, 5 has no other adjacent vertex, but you cannot write 1 because 1 is already written, so we don't repeat. After 5 there is 4. So 4 also has only one adjacent vertex, that is 1. You don't write it because we don't repeat. Now come on 2. So when you come on 2, you find that 2 has multiple adjacent vertices like 3, 6, 7, 1. 1 won't be written because 1 is already written, but 7, 6 and 3 are not written. So we will write them in any of the order. And the concept is same. After moving on from 2, we come on 7. But adjacent vertices of 7 are only, there are no adjacent vertices of 7 apart from 2, and 2 is already written, so we won't repeat, and same goes for 6 and 3. So this is how BFS is. You have to select any of the vertex from the figure and write its all the adjacent vertices. Then you move to the other vertex and you write all its adjacent vertex. But important point to remember is we don't repeat any vertex if once written. Next comes DFS, depth first search. First step is same, Select any vertex from this figure. I will select the same vertex so that you all don't get confused. 1. Step 2 in BFS was write all its adjacent vertex in any order. But here in DFS you don't write all the adjacent vertex. Select only one adjacent vertex, but any one. So 1 has 3 adjacent vertices, 5, 4 and 2. I will choose 5. No, wait. To make your concepts more clear, I will choose 2. When you come on 2, you don't write 5 and 4. Fine. Only one need to be written, not all the adjacent vertices. When you come on 2, now you will write any one adjacent vertex of 2. So here I see 7, 6, 3. They are also the adjacent vertices of 2. I would not count the 1 because 1 is already written. So out of these 3, you have choice. You can write any one, not all the 3. So suppose I have chosen 6. Means I came on 6. But now further 6 has no other adjacent vertices. 2 is there, but 2 is already written, so we don't write it. So we come back to 6 because we went to 6 from 2. So we will come back to 2. From 2 we will come on other adjacent vertices. 3. So you write 3. 3 has got no other adjacent vertices. So you come back again on 2. From 2 you see that whether 2 has any other adjacent vertex also. So you find that 7 is also the adjacent vertex of 2. So you write 7. But 7 has no other adjacent vertex. So you come back on 2. From 2 you see that now all the adjacent vertex of 2 are written. So you come back again on 1. When you come on 1, you see that you have written earlier 2, but apart from 2, 1 also has adjacent vertices 5 and 4. So write any one of the 2, you come on 5. When you write 5, you see that 5 has no other adjacent vertex. So you come back again on 1. And from 1 you see that 4 is the last adjacent vertex left to be written. Now 4 also has no other adjacent vertex, and 1 also doesn't has no other adjacent vertices.